Hey guys, today, wait, let me just, never mind, I gotta read this. Alright, anyways, hey guys, I'm Ben Hartley. I'm gonna teach you guys how rechargeable batteries work. First of all, I want to clarify something. Non-rechargeable batteries and rechargeable batteries work in exactly the same way. Through an electrochemical reaction involving an anode, a cathode, and an electrolyte. In a rechargeable battery, the reaction is reversible, allowing us to use them over and over again. This may sound familiar because in topic 9, we learned about redox reactions. But rechargeable and non-rechargeable batteries work in a way that's called, or they work as a voltaic cell. Before we move on to learning about rechargeable batteries, let's just go over how voltaic cells work.
As you can see from the diagram, copper is oxidized at the anode and silver is reduced at the cathode. When copper is oxidized, the electrons flow through a wire, creating a circuit which produces electricity. The salt bridge is so that ions can freely move between each solution. Each solution is what's called an electrolyte, meaning that it is a place where ions and electrons can flow and is a good conductor of electricity.
Huzzah! Electricity is produced! Anyways, in fact, rechargeable batteries work in exactly the same way as regular batteries. And technically, regular batteries are also rechargeable. Any kind of battery is actually technically rechargeable, but once you can pass an electrical current through a battery, the reverse reaction occurs. This is called electrolysis. In this reaction, anions are oxidized and cations are reduced, which is the opposite of a voltaic cell. Let's look at the reaction that happens in a battery.
As you can see, the three primary components of a lead-acid battery are lead oxide, sulfuric acid, and water. Below is, or you're looking at the reaction that happens in a lead-acid battery, and basically, the problem is the H2O. As you can, or from the reaction, you can see how electrons are, or what happens at the anode and the cathode, negative and positive, etc. But the problem is that in the reverse reaction, when a battery is charged, water is dissociated into oxygen gas and hydrogen gas, which is problematic because the hydrogen gas can stockpile and build up pressure inside of the battery until the battery eventually explodes. Not to mention the heat factor that comes from charging something, meaning that because hydrogen gas is very flammable, when it explodes it can be very fiery, and that's no bueno.
Now that's what I call some pretty neato chemistry. Essentially, all we had to change about a regular battery to make a rechargeable battery is make it not explode. To make the batteries not explode, we had to move away from hydrogen-producing batteries like lead-acid batteries and towards batteries that produce less hydrogen during electrolysis so that they don't explode. Now that's what I call a salting battery, right? Because the batteries explode.
Yeah.
And they're assaulting you.
Is that the whole one?
Anyways, examples of rechargeable batteries include the lithium-ion battery and the nickel-calcium battery. Thanks for watching my electrifying explanation.
Lashing out the action, returning the reaction, torn away. Hypnotizing power, crushing all the coward, battery is here to stay. Smashing out the boundaries, found me, cannot stop the battery. Pounding on aggression turns into obsession. Can I kill the battery? Can I kill the battery? Do 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 do.